Hi. See, that worked. I got rid of all the nerves, so that's good. Hi, my name is Hannes. Today I'm going to talk about Lego and marbles. So first of all, I suspect that about half of you are here because the title of my talk disrespects Lego, right? And you came to see what that was all about. Now, first disclaimer before we start this talk. Our household is very much a Lego household. Like the last victim was my wife, but then Lego came out with all of these great floral sets and she's hooked as well. So everybody does Lego. This is a set, and at the risk of showing my age, this is a set that I used to dream about as a kid. The 8094 Control Center. It is basically the predecessor of what Mindstorms became to be. It was all wired and very rudimentary. And if the batteries died, like your programs didn't exactly do what they were supposed to do anymore, but it was great. But I think marble tracks are awesome as well. Like, who here during COVID watched those marble tracks that were commented on, like Formula One races? Yeah? Yeah, we all binged those, didn't we? But marble tracks are awesome. And this is my oldest talk. I wrote it in 2018. And the weeks before I first wrote it, my kids did this. And what you can see here is like there's some Duplo support here, and Duplo is a Lego product. And they used that as a support because they didn't have enough blocks to build their marble track. So we can always coexist between marbles and Lego, right? Now, second disclaimer, this talk is not going to be about hipster frameworks or fancy libraries. We will, in fact, just be talking about good old code structure. If that makes you want to walk out to another talk, please feel free to do so. And then a service announcement. Lego is a brand name and it gets used as an adjective. So you say Lego set, Lego brick. You never say Legos. If you say Legos, you piss off Lego people, right? Don't do that. But even this is a service announcement from the Lego website itself. So use it as an adjective. Just makes you look foolish if you say Legos, just so you know. Now, before I dive into the technical parts of what I had to do to make all of this work, let me sketch a picture of what the environment was that we were working in when we needed this solution. Now, I was working for a company that was a huge IoT integrator. So what we had is this embedded gateway that was running on embedded Linux, and we had this mechanism of plugging bricks into that, not Lego bricks, but like bricks was actually a small print that had a zero force insertion socket, but that was actually electrically, that was a USB connection. And the cool thing is, on those USB devices, we could have antennas for different types of IoT devices. So if we had to deal with a different frequency or a different protocol, our hardware designers would build a new brick, we could plug that in, and that allowed us to talk to virtually anything, right? And the goal of this platform was to have that gateway inside a home, and that would talk to all of the different IoT devices, and then we could integrate that in a central platform. And from that platform, with an app, you could control your devices, check your thermostat, all that sort of stuff. And the whole thing was deployed in one big multi-tenant backend. So all of our customers, because we usually talk to integrators, so we didn't sell directly to the end customer. We usually went through people who sold IoT devices or people like electricity companies. Because, for instance, in the Netherlands, it's very common that the electricity company also installs your boiler and your thermostat and that sort of stuff, and they do maintenance on them. So we had some monitoring for that as well. And every implementation that we did was a new type of device. And in our code base, that meant that we would often write code to talk to those devices even before we had a contract with our customer. So we were talking with someone like, hey, can you control our devices with your platform as well? So we would build a proof of concept. And as these things go, they came all the time. So we were basically, that was the main job of our team, is doing all these integrations, but not all of the deals went through. In fact, only about a quarter of the deals went through, which means that 3/4 of the devices that we implemented never saw the light of day in production. But our product people had this sunk cost fallacy problem in their heads, like, yeah, but we've invested in this code, so we're not going to throw it away, right? Sound familiar? Who has had that? Maintenance hell, yeah? We've all had that. And this led us to think about how we could structure that code a lot better so that we could basically deal with the situation. What we wanted to be able to do is take a wrecking ball to that code. All of that code that never went to production because there was no deal with the customer, the devices were not live, that needed to be taken out. And if you would ask my two sons which one of these two you would need, they would disagree because they have different favorite colors, but they would both agree that they need one of those. And there's this famous quote from Kent Thompson saying, "One of my most productive days was throwing away 1,000 lines of code." And that is how we felt all the time. We wanted to take a wrecking ball to that code and get out all of those devices that were just getting in the way of refactorings, getting in the way of maintenance, and that was really frustrating to us. So of course, we first talked to our product management and asked them, like, hey, can we just throw away this code? And they were not really ready to give up on that. And we were not in a position where we actually could win this argument because the head of product management was also the CEO of the company. So he made it very clear that he expected us to keep all that code around. So we figured, like, is there a way that we can deal with it so it's not painful to us, but we can still keep that code and resurrect it when we need it? And that is what led to the story that I'm going to tell you today. So the dev team, what we wanted is we wanted to be able to very quickly implement new device types. If we saw a new device coming in, we basically wanted to write a quick and dirty implementation for it, and then maybe refactor that if the deal went through and we had to put that in production. But what we also wanted is as soon as we got to a point where the deal did not go through, we could just take it out of our deployment and get rid of it, like park it to the side. And that meant that we would have to limit our dependencies between our core platform and all the dependencies that we had through those devices. And that led us to make our abstractions in our code base a lot cleaner, and it made us think about all of those things. So you're probably already thinking in your head, like, okay, Hannes, you're going to do microservices. Now, if you have, I'm going to park that question for a second. If you have read my Twitter tagline, you will see that I am a monolith advocate. So I don't think microservices are necessarily the solution to every problem. And there is a good reason for that. And I've been coaching developers for more than a decade now. And I've seen a lot of developers go through the same path. And I'm talking about, I'm coaching .NET devs, so let's generalize a little bit, like object-oriented backend developers. First project you do probably ends up looking like this. Maybe in college, maybe in your free time. But what you do is you copy-paste some code of the internet, you make it all work. When product management needs new features or you need new features, you drag in more code and it becomes unmaintainable really quickly, right? We've all had a project like that. Hopefully you get this out of the way before somebody is paying you to write code. But hey, we all do what we gotta do, right? So when you make this mistake, you fail and you learn and you realize, I can never let it get that bad again. How can I make sure that I never let it get that bad again? And then we think about layers. Somebody teaches you about layers. And for those who were in my workshop this week, we had this discussion very briefly. Like, layers is still the state of the industry if you listen to college professors. Like, layered architecture is still something they teach in college today. And what they teach us is like, yeah, you should have everything clean. You have a database at the bottom and a UI at the top, and every layer depends on the next. Bonus points if you deploy them separately, then you can call them tiers, but it will still be a layered architecture. And the problem with that is that change ripples through from the bottom to the top. So if you need a change, you're still touching all of the code, right? And the reason for that is if you put your architecture this way, what you're essentially doing is putting your database in the center of your architecture, because everything points down to the database. So every layer consumes the next. If you consume cake, you eat all of them at once. It's very tasty. So you realize after a while that layers is not the solution to your problem. So you learn more. Somebody tells you about Solid, and you think, yes, this is the solution. I'm just gonna write Solid. But what I've seen is a lot of code bases that still look like this. They apply all these patterns. I've actually worked in a code base where all of these got implemented for every single API call. And a lot of those classes were one-line calls to the next. That meant that we had a whole bunch of classes that didn't do anything, right? That is not what Solid is. And at some point it clicks, and there's always an appropriate XKCD comic for everything. I think Randall Munroe is fantastic. If you've never read the What If book, you really should. It got me like spitting my drink a couple of times, and my wife was wondering what I was actually reading. But Solid, at some point it clicks. And for me, what made it click was the realization that if you have an interface, it should be owned by its consumer and not by its implementation. Because that's the only way that you can predefine the behavior that you expect from something instead of first writing some code and then doing extract interface, because it will always be something that one-to-one matches your implementation. It's not necessarily the best way of thinking about it. And that, for me, made Solid click into place. And that is why I had a title of this talk. If you take the Lego castle on the left and the marbles on the right, and you have to replace the blue with the green in both scenarios, on the left, that would actually be really tricky, because I'm kind of an asshole, so the gray walls go into the two towers on the outside. They're high enough so that you're deconstructing part of the yellow and the red tower to just put in the green one. You're going to have to tear a whole lot of stuff down and build it back up again. And I feel that often when we are refactoring code, it feels like that. You're touching a whole bunch of stuff just to make the one replacement that you really want to make. Now, if our code were more like a jar of marbles, we could just spread them out, take out all the blue ones, pour in the green ones, and we'd be done, right? Proper solid code is what looks like the right side. It's like marbles. And it makes it a whole lot easier to refactor in a code base where it is easier to remove stuff and put it back. Now, solid is one thing, but you can also do it at an architectural level. Because all of the things that I've talked about right now is stuff that happens inside a single deployment unit, but sometimes your systems grow and they become more complex. And I feel like you should only be messing with that after you understand what goes on inside a single server and service and how you can make that clean. And there are a whole bunch of ways to do deployments. I feel like our industry is defaulting to, if you want to have multiple things going on in your architecture, you should be doing microservices. There are different ways of dealing with that. And as an OO dev, like when you master all these things, I feel like you graduate and you know what you're doing as a senior, right? So let's get back to my parked question. We parked that question about microservices. Now, the problem was our team wasn't at step 5 yet. We had a lot of juniors. We had a lot of people that were actually onboarding and leaving the team. We had a lot of churn, and it made it really hard. And I stole this image from Martin Fowler, and it's true. Microservices are a fantastic solution to a set of problems, and once you get those problems, there's literally almost no other way out. Especially when I think about having multiple teams working on the same product. At some point, you will have too many teams and you can no longer get away with a monolith. You'll probably end up cutting it up into services. If you need different technology stacks to implement your solution, that's a technical reason to do microservices. But also, if you need to scale certain parts independently, at some point you may need microservices. But our team wasn't there yet. Our code base looked a little bit like that. It wasn't as bad as the worst I've seen. And we already had a little bit of distribution going on because it was already cut up into, how we call it? It was basically a distributed monolith because it was all writing to the same database, but they were different services. We made our lives really hard. And I think the first rule that we need to take away from this, I'm paraphrasing here because I really like the Fight Club movie. But as long as you can get away with not distributing your software system, you're probably going to be happier for it. And since we were a single team working on this, like shipping it as a monolith actually made kind of sense. Now, if I would have to make a quote about this, never solve a code problem by introducing a deployment problem, because you will run into the wall, right? It's usually not a solution to something that you cannot solve on an atomic scale inside a single service. So the challenges that we were faced with is what we actually want, and now we're going to get to the technical side. Our monolith was an ASP.NET application. We had a REST API that was the entry point into everything that our backend did. And what we wanted to do is for every device that we added to our backend, for new controller methods to appear. We also wanted them to extend existing controller methods. The existing controller methods had to do different stuff depending on what we posted to certain APIs. If we would post something for a specific thermostat, maybe we would have to run some custom code. But we didn't want to have different thermostat APIs for every different thermostat that we supported. There is a central functionality as well. And of course, all of that had to write to a certain database, and we needed to migrate that database. And the best way of getting me to do something is tell me that it's impossible. And it's funny, before we started the talk, we were talking about Entity Framework. One of our devs told me, like, Entity Framework can never do that. You're never going to make it work. And of course, that triggers me, and I'll try to do that. So we figured that with plugins, we could get all the things that we wanted. Have a single deployment unit, plug in assemblies with extra functionality that would enable all the things that we wanted to do. So we built a successful proof of concept, but this is a while ago. This was .NET 4.7 times with, at that time, I think Web API 2 or 3. And we started doing this, but it wouldn't be interesting today because a lot of the complexity that we had ran into at that time has now been solved in .NET Core. So this is where my story will divert from what we actually did into how would you do it today in a modern .NET stack. And the first thing I want to tell you about is onion architecture, and there's many different names for onion architecture. The term onion architecture comes from Jeffrey Palermo. He used that in 2008. You may notice that this is before the Clean Architecture book was written. But you may have heard of it as hexagon architecture, ports and adapters, clean architecture. All these things are very similar. They're not exactly the same, but very, very similar to one another. And the thing that they have in common, remember that I told you that layered architecture is basically putting your database in the center of your architecture. All these architectures are basically putting your domain code at the center of your architecture. And that makes way more sense because if you need to change something in an application, your domain is the most important bit. It should be in control of all the things. So all of these architectures focus on two things, like shielding all your dependencies with abstraction and having very nice isolated domains so that you can very easily test it. Now, how it looks like, the way that Jeffrey showed it in his articles from 2008, is you put your domain model, and that's mainly your entities, at the center, and around that you write your core domain services. That is your core domain logic. The stuff that doesn't change as use cases change. The stuff that doesn't change when you change your UI or your persistence layer. And all of your references only point in. So every layer from the outside can reference the domain model, but the domain model can't have any references. I'll possibly make exceptions for things like a datetime library, like no.time, but like that should be kind of reference-free. It should be a bare class library with nothing in it. Well, code, but no dependencies. And then around the domain services, you're going to write your application services, and those are your use cases. Very similar to clean architecture, where basically the center two layers are like combined into one. And then around that, all of your other stuff is integrations, because what you'll do is in your application services, you're going to define the interfaces that allow the outside to talk to your model, and then you will implement them from the outside layers. So when you talk to your file system or your database or even a NuGet package, what you do is you implement an interface that was defined in your core, and that way you shield your implementation from your domain. And remember that I said what made Solid click for me was that interfaces are owned by their consumer. That's exactly what this architecture forces you to do, because before you do an implementation, even of your database repositories, you're forced to think about what interface do I want to be implementing here so that it works for my domain model. So this forces you in the right direction. Now, the benefits to me of doing this is that there's no dependencies that can actually leak into your core, and all your dependencies become very replaceable. Think about our marbles. We can very easily take something that is in that outer layer, write a new implementation for the same interface, and be sure that all of our essential code, our domain code, still works, right? So it forces you in the right way. Now, if we look at testing, also that story becomes quite straightforward, because your domain model and your use cases don't have any dependencies. Writing tests can often even be done without mocking anything, because you have very predictable behaviors. Sometimes you have to mock some infrastructure stuff, but even that is all going to be hidden behind very clear interfaces that are a lot easier to mock. Because what is the problem if you do a right-click extract interface is that you get a very complex one that is not that fun to mock when you're doing unit tests. All of your integration tests go against your infrastructure layer. And the cool thing there is that they will not require you to do anything with your domain model, because you have an interface to what you want this dependency to do. Write something to a database, writing an integration test for something that lives there is actually very straightforward. And obviously, you can do UI and acceptance tests for your user interface. Everything nicely points in and is easy to test. Now, sometimes you need weird stuff, and I'm going to use this as an example. Like, at some point, you need a DI container in the story to tie some stuff together. And if you want to implement a service locator because you need it in your domain code, and why we need it, I'll show you that in a minute. If you need something like that, what you're going to think about is, what do I expect from my DI container? And you write that contract in your core. And then you look at available packages on the market. We used AutoFac, for instance, at the time. And then writing an implementation that consumes AutoFac and implements those very few functionalities that you require from a DI container is actually not that hard to do. It's going to be pretty straightforward. And that is how you do all your integrations from packages, is you think about what you expect from it in your core, and then you write those integrations. And that is how you can consume all kinds of libraries, but keep them out of your domain code. So when we do this, it limits the contact surface between your packages and the way that your code consumes them. And that is often the tricky thing. If we drag NuGet packages into our solution and we just leave them exposed, that means that every dev is going to use them in their own way. They're all going to use different functionalities, effectively making them impossible to replace. All right, so that's the kind of stuff that we need to think about. So when we think about our integrations this way, we will have happy developers sitting in the wood anxious that their laptop is going to die because they don't have a power outlet, right? I don't know who makes these kind of stock photos. Doesn't make sense in my brain. I get anxious when I see that, man. But we can make stuff not leak into our core, and all of our tests are easy to write, all of our integrations are easy to write, and it makes our life as developer in the long run so much easier. So let's talk about plugins. And we're living in an age where we're all plugging in our car. Who here is driving full electric already? Yeah? Range anxiety, a thing for you? Not really, is it? No, you get used to it really easily. I feel like range anxiety is something that people who don't drive electrics invented to mock the people who drive electric. I have zero range anxiety about driving electric. I think it's great fun. Now, plugins, what we wanted is we wanted to have a way to plug our new device implementations into our core and deploy them along with our application. And we wanted to make them as easy to develop as humanly possible. And they had to seamlessly expand our core functionality. As I said, we wanted to maybe run some custom code when certain central APIs were called on a device type that required some extra steps. And the cool thing is, what we really wanted is we take that assembly and put it in our deployment pipeline, and that will enable everything. And if we remove it again, all of the functionality is gone. That way, it would allow us to write new implementations quick and dirty and refactor them if we had a deal with the customer. That meant that we could not have any references in our core to all of our device types. They had to point in, basically blowing up that onion architecture ideology to a bigger architectural idea as well. And that works really well. We wanted to have some rules. Great movie, by the way. The plugins could only reference our core because that's the only way we could make it work. And we did a whole bunch of stuff by convention because, well, we were in control of the entire solution, not just the core, but also the plugins. So we could get away with a lot of convention stuff. If somebody else is writing your plugins, you may have to code a little bit more defensively than we did. And we should just be able to deploy them, and they should not break anything when we remove them. And that turned out to be a little bit trickier back in the day. Nowadays, it's actually gotten a lot easier. So let's dive into the code and see what we need. And the application that we'll be building today is a toy collector. We're going to be collecting toys, and we're going to start with Lego and with marbles, but we might collect any arbitrary type of toy. So I'm going to walk through these 6 things, and hopefully that will be before the end of the hour, so I can let you go and have some coffee. But these are the things that we struggled with a little bit when we were implementing all of this. So I'm going to walk you through how you solve those problems. And it has gotten so much easier in modern versions of .NET. So dealing with our DI container was the first thing, because we needed to scan all of the plugins at startup, which meant that we needed to use some reflection to find some service locating code inside our plugins to find all the new services that we implemented in each plugin when the application would start. We made type registrars in every assembly that we wanted to be scanned, and that actually worked really well for us. Now, where it became painful is because your startup project in your IDE doesn't have a dependency, a project dependency to your plugin, that meant that your plugin wouldn't automatically build when you would start up your application. Now, there's a couple of ways to solve this. We did it with copy the plugin in the post build actions. That worked. You can also make a development startup project that calls your startup project and has all your plugins in it. And that is probably the easiest way to get around that. And nowadays, when you start up ASP.NET applications, basically what you're calling is the host builder. You can call that from another startup project and solve it like that. And that's the way that is the easiest way to get your development environment to do what you need it to do. Now, our type registrars, what we did is we just had a wrapper around the service collection in .NET, and that wrapper just allowed us, again, that is an interface that we defined around what we expected from our DI container. With that type registration container, we could just register all of our types. Sorry. So what that led us to do is we had type registrars that we could run in every single assembly that we would scan. And all it would do is it would register all the services that we had in that very simple class. Now, ASP.NET was another tricky thing. And remember, we wrote this in old ASP.NET times. If you want to add more controllers to a running application, that used to be very tricky. You had to write a custom controller locator. You had to find your views in a different way. Now, what you can do is you can basically add other DLLs in ASP.NET Core, and for that you can use even the compiled Razor assembly parts to get Razor views from other assemblies as well. So all you need to do at startup is basically run code that looks a little bit like this, where we do application parts.add, and then you can add controllers from other projects into your running ASP container. And you have to just make sure that the routes don't collide, but apart from that, it's all fine. So just calling this little bit of code solves that problem in modern C#. In old C#, you had to write a whole bunch of code. It was possible to do it, we did it, but it's so much easier today. So what we do is we just scan all of our plugin DLLs, and if they have ASP.NET into it, we just call them in this way. Now, also fun, I feel like I have a flashback to the beginning of the week. One of the things you're inevitably going to have to deal with is polymorphic deserialization. I see, yes, he's nodding. He was in the workshop. Polymorphic deserialization is you are able to post polymorphic types to an API endpoint. Let's say that we post a toy to one of our controllers, but in the backend we want to either process it as a Lego set or a marble. That means that our serializer has to somehow understand what I'm posting. And in XML days, this was really easy because we had opening and closing tags. So we could just say, hey, I have a Lego set here, and all of these properties until we're done is a Lego set. And your serializer would just pick up those tags, and you would be done. Now in JSON, well, if I'm posting to an endpoint that accepts a toy, how am I going to know that this is a toy, that this is a Lego set and not just a toy? And what most serializers will do by default is drop all the properties that are not in the toy base class. So you're going to have to work with that. And if you've used Newtonsoft JSON before, you could do this, type name handling auto, right? Who has used that before? Yeah? Okay. Like, I'm going to make you really anxious about this. This is a huge injection risk. If somewhere in your API contract you have something that either accepts object or dynamic, this exposes full-on remote code execution on your APIs, because you can use that to create file handles, write to that file, execute it, whatever you want, because you can instantiate any arbitrary class through the .NET framework. So there's a reason that this didn't get ported from Newtonsoft JSON to System Text JSON, because James Newton King is working on that. This didn't get ported for a reason. So what we do now, what this allows you to do, for those who haven't used it, is you have a $type attribute that you can post into any class that will just tell you, like, you can deserialize this as, and then you pass in the fully qualified class name. Now, this is not good, so let's do a proper way. You can write very much of the same behavior, but if you write a proper JSON converter, you can basically limit which types something can be deserialized as, and thus protecting against said injection attack. And we can still use the string values, and what we can basically achieve if we write our own is that we also no longer need the fully qualified class names. We can use something shorter, something cleaner that is easier to consume, right? Now, you register it in your startup code, and once we're done with writing our own custom JSON converters, what we can just do is $type Lego set. Much cleaner, much easier to integrate with, and that's the way that we ended up doing that. Now, logic and extension points are another thing, and that is actually one of the easier ones that we needed to do. Let's say that you have a core API where you want to maybe run some custom code depending on what got posted, because we now have this polymorphic deserialization, which means that people can post Lego sets to our toy APIs, but maybe for Lego we need to run some extra. For that, we need to make an interface extension points for the plugin to actually have some code to run, and then we can just implement that on the plugin side. But for this, what we need is a service locator that can actually resolve code based on runtime types, because when you have your injection happening, for instance, if you use constructor injection on an API controller, all of that injection will happen before you know the runtime type of what gets posted to that API, right? So you're in a little bit of a situation where I'm only going to know the type in a bit, and then I'm going to need to resolve code to do it. Now, it turned out to be not that tricky. So what we ended up was something like this. We had the toy creator custom logic, which is basically the interface that we could use to resolve the class that is going to execute that extra code. Then you make a generic version of that. The reason that we did it like this is this gives us an execute method that accepts the super type, and it saves us a bunch of reflection code. Now, with that scoped service locator, it is basically something that wraps around our DI container that allows us to resolve something in runtime types. So what we get here in our create type, and we get into our run custom logic, is we can figure out what type of toy are we actually getting here and using that to resolve our implementation of that custom logic, and then just execute it, right? So whenever we needed extension points for custom IoT devices, this is the approach that we took, and only one or two might actually implement them, and for all of the rest, this would just do nothing. Pretty straightforward approach. And then Entity Framework. And I'm a bit passionate about Entity Framework, I always have been. I wrote a course on it recently as well. If you're interested, shameless plug, you can watch it on Dome Train. The thing is, Entity Framework needs three things to function. It needs to know what your classes look like, it needs to know what your tables look like, and it needs to know how to map between those two things. A lot of that happens by convention, right? But it needs those three things. If you have been using Entity Framework since the early days when we still had those great EDMX files, you could see those three parts, right? The storage schema definition language, and then the conceptual schema definition language, and then the mapping schema. That was always merge conflict hell, those files, right? Who has been there? Yeah. I'm glad that we're rid of it. But it's not because those files no longer exist that Entity Framework doesn't need this info anymore. But the cool thing is we can feed a lot of that information at runtime. We can just do Entity, and this slide is out of date actually. It used to be able, in Entity Framework Core, you could only map inheritance in your database in one way. Basically putting all the fields in a single table and then have a discriminator that told you what type of record it is. Actually, since the last version of Entity Framework Core, you can also do the other two things that Entity Framework 6 could do, which was put it in separate tables or even have only the bottom tables and not the abstract top table. Now, the problem here is that we used to have a problem when we would fetch data that was created by plugins that were no longer in our system. because we would have records in our database that said, for instance, let's say that I would also collect Matchbox cars. If they were in the database and I remove the Matchbox plugin and my entity framework fetches a bunch of data, it would see a discriminator that it didn't know what to do with, and it would actually crash the code. So we had to very consciously only fetch records, and we had to extend entity framework to do that. Now, the cool thing with EF Core is if you have some kind of inheritance happening, entity framework automatically already adds a where clause about the types that it knows about. So you're getting this one out of the box for free. But what we needed to do is then feed all these new types into it, because our Lego and our marbles, they're living in separate assemblies, and we're starting up a core project that has no references to them. So to make that happen in the on-model creating, is we would just inject a whole bunch of extensions into our DB context, and they would just do something like this. So we had a very simple interface that would took the builder in, and that builder, obviously because it is domain code, it could not have a reference to entity framework, but the implementations could, and there we would tell it about the mapping of all of our different IoT types. And in our DB context, all we needed to do is just scan through the assemblies as they were injected. I have about 15 minutes left. Database migrations is probably the last one that we need to tackle, and there we can take two different approaches. And it is also the most messy bit of this entire solution. You can basically take a central approach or a distributed approach. In a central approach, what you would basically do is treat your database migrations as a one-time thing that included all of the plugins. So what you would do is you would make a startup project that had all of the plugins and generate your migrations off of that. If you take that approach, you can use Entity Framework Core migrations and it will work just fine. Now, the problem with that approach is it's not really clean. It has all of the fields for all of the plugins for all eternity in your database, and you might not be using a lot of them. It also will have, in certain, that has been fixed in recent Entity Framework, by the way, but it will have to require you to deal with your migration history table. Because it used to be so that Entity Framework would actually fetch like the latest migration and check the model that was in there. It no longer does that. But it used to check it, and it would throw an exception and just stop functioning if the model in your migration table didn't match the model that it had at runtime. So that's something that was really painful. So what we did with our migrations was just rename the table after our deployment was done. And if it didn't find the table, it didn't check. That was good. The other approach, which is a lot cleaner, is keep your migrations with your plugins. But that has other problems because they're trickier to test if they collide with one another. And it also requires you to do some runtime checks whether all of the migrations have been executed, because you might start up a program with new migrations and that they have to all, with new plugins, and that would have to run the migrations. Now, the central migrations were easy. We had a central migrations project. We could load all of the plugins, and it takes your startup project by default, so we could basically get that done in this way. If you've done Entity Framework Core migrations, this is what worked. Now, as I said, if they're all loaded, they don't match. Distributed migrations, you could use something like Fluent Migrator, and this will look very similar to Entity Framework Core migrations, except you're writing them by hand. And you have two paths to success here. Either you do a runtime check, but that requires that your application has the ability to change your database schema, and again, that makes me anxious. Or you make sure that when you enable new plugins, that always goes through a pipeline and you run your migrations there, and that is probably the better approach. But in order for this to work, we can no longer rely on Entity Framework Core migrations. It's not flexible enough to do that, so we do Fluent Migrator. But it looks very similar. This is what a certain migration could look like, and it's hand-coded. And it's not really that much harder than writing the SQL code that will create this same table. It's a very nice builder API that lets you create tables, modify columns, like all that sort of stuff, all the stuff that you're actually used to seeing when you run Entity Framework core migrations. You can find very similar stuff in the Fluent Migrator API. Now, the cool thing about these is they all have a number at the top, the migration number. And it doesn't care about what has been executed, which migrations come before it or after it or whatever. It just scans which ones are already executed, and then it scans which migrations it knows about, and it will just execute the ones that are not executed yet in order. Which makes total sense for our scenario, because when we're adding a plugin, those migrations might fit in between other migrations that have already been executed. And Fluent Migrator just goes like, okay, I haven't executed these yet, just executes all of them, and hopefully you don't have any SQL problems when you do that, and they will just execute. And the cool thing about this is you can keep your migrations with your plugins, which makes sense in your head as a developer. So all you need to realize, and that's the only tricky part about Fluent Migrator, it has this builder.scanIn method that scans the assemblies that you pass it for migrations. The problem about that is it gives you the impression that you could call that multiple times, and you can't. You have to pass in all of the assemblies in one go, because if you call it multiple times, it just takes the last time that you called it. So be aware of that. It's the only one thing that is tricky about Fluent Migrator. And what that left us with was an architecture that looked like this. We had our core in the center. We had our database project referencing the core, and our API referencing the core. We had a project for all of our DI wire-up that needed to happen. Our migrations just point at the data project. Our plugins just point in. Our tests point in. Everything was nice and clean. And we found this so easy to add new plugins and to evolve our core as well, because it was isolated from everything else. So let's wrap things up so you can grab a cup of coffee. The key things that I want you to take away from this session is, before anything else, structure your code. Make sure that the code inside your single project is easy to deal with and easy to evolve. It's the thing that's going to cause your team the most friction in the long run, and it's worth investing time in. Plugins are not really that hard to do, but I feel like that message gets lost in our microservice industry. But especially in ASP.NET Core, it's almost as if a lot of the stuff that we need to do plugins is already there out of the box. You don't really need to write a lot of custom code. Most of the tricky code I've shown in this presentation, and I think I've only had like 10 slides with code on it. And never solve your code problems by introducing deployment problems. If you're going to quote me on anything, that is the thing you can quote me on. I don't mind. And don't worry where you are in your journey, because I'm still learning. I hope that you're all still learning. It's definitely why we're all here at a conference, to share experiences. This was mine. I hope you share yours with me as well. Now, I get a bunch of questions. I've been giving this talk for a long time. This is the first conference talk ever I wrote back in 2018. And I've compiled a couple of things that people asked me after the talk, so I'm going to go through them. If you have more questions, you can come talk to me afterwards. Isn't this a lot harder to code? Actually, we didn't experience this as very tricky. The system that we had before it was way trickier to evolve, and it made our life a lot easier to do things this way. Can your plugins be onions themselves? Is a question I had a couple of times, and yes, definitely so. It's actually what we did. Our plugins were their own groups of assemblies, so it wasn't a single DLL. A plugin was usually a bunch of DLLs. But for the sake of this talk, that would have been a much harder story to tell. But yes, you should definitely consider doing that, because then every plugin has their own domain code and their own API code and so on around it. And also the plugins will be very clean. And when should you be doing this? Well, there's a couple of reasons to do this. Onion architecture, I wouldn't see why you wouldn't put your domain code at the center of your architecture. I think it makes even the simplest projects a lot easier. And it usually doesn't require any special things that you should be doing. The only thing it requires is that you fight your frameworks a little bit. Because if you do final loop project in ASP.NET, what you get is basically something that points down completely, right? So you should just think about it, but it doesn't really add friction. Plugins is a different story. Plugins make sense in a couple of scenarios. Plugins make sense if you need, like our case, like modular deployments. If you want to enable and disable functionality at will, or if you have customers that have their own deployments that have paid features that you want to be able to enable and disable, it's a perfect solution for those things. If you want to easily retire and replace stuff, you can write a plugin quick and dirty and then replace it with a proper implementation later, or entirely replace an implementation if you so please. You can use that for A/B testing, obviously, because you can just write 2 versions of something and then separately deploy them. And it also makes your build pipelines a bunch smaller, because every plugin can have their own pipeline, and then you have your deployment pipeline that pulls in your artifacts from your other pipelines, meaning that you will have less wait time between the time that you write the code and you actually have artifacts that you can work with in your deployment system. Because you don't have to build the entire system every time. If a single plugin changed and you want to deploy that, is something that this architecture could easily help you do. And then there is the 10-100 rule. And I call it the 10-100 rule, but I didn't invent the rule. The 10-100 rule is an idea that I learned at an NDC from Udi Dahan from Particular. And he didn't phrase it as the 10-100 rule, but what he said is basically, wouldn't it be cool if you as developers could talk to your product people and you don't really fight them on whatever they want, but you have an agreement with them that you can write any feature quick and dirty. You can just hack it together and put it out there. And you put an expiry date on it. It's like, in 2 weeks, we're going to decide if you want to keep it, right? And if you keep it, that means that we're going to throw it away, and then we're going to spend 100% of the effort, not 10% of the effort, 100% of the effort to do a clean implementation. But if you don't keep it, we will have invested only 10% of the time to do the quick and dirty version, and we're just going to throw that away. The cool thing about this is, if you do that, what you're able to do is basically try out 10 features, keep one and rewrite it properly for the price of only 2, right? And that's our reason for being as software developers. We deliver functionality to a business. We support something, right? And I think this is a very efficient way to do it. Not with the product team that we were working for. If they are unable to throw their code away and you cannot get them to agree on that deadline where the code will actually expire, you're going to be facing maintenance hell again. But if you can get them on board with that, I find it an extremely productive way of trying out things and only investing real effort in the things that are worth keeping. Right? I'm going to let you have some coffee. That was my talk. If you have questions, come and find me. I'm going to clear off stage so the next speaker can come and set up. Thank you so much for being here. Enjoy the rest of your NDC London. Have a very nice day.